afternoon, students. Now, in the last lecture, we have studied how to convert the given rational number into decimal, whether it is recurring or terminating. Now, we'll see. So, in the first bracket, this 2 root 2 is there. Here, root 2 is there. These are like terms because root 2, both side common. So, that will take in the one group. 2 root 2 plus root 2. Here root 3 is there, here root 3 is there. So that we take in one bracket 5 root 3 minus 3 root 3. So of the which irrational number is same, that two numbers we have to get together. Here also this irrational number is same, that we are taken together. Now here coefficient is not there. This root 2 and root 2 is same. Here coefficient is not there. So this is taken as the 1. So this 2 plus 1, that is root 2. This 2 is coefficient, here 1 is. So 2 plus 1, this common is root 2. Plus this 5 root 3 and 3 root 3. So 5 and 3 are coefficient and root 3 is common. So 2 plus 1, that is 3 root 2 plus 5 minus 3 is an irrational number. So when we add the rational number or take the difference between rational and irrational number, the answer is coming maybe it is rational or irrational. So sum of the rational and irrational number is either it is rational number or irrational number. So in this way we have solved this example. Now further we cannot solve because here root 2 is there and here root 3 is there. You are knowing the like terms. These are not like terms, so we cannot add further. So this is the last step of this answer. Now again I explain. These 2 root 2 and root 2, they have common root 2, so that we are taken in the one bracket. This root 3 and root 3 is common, so that numbers we are taken in one bracket. Now here coefficient is not there, so it is taken as 1. So 2 plus 1 root 2 plus 5 minus 3 root 3. So 2 plus 1, that is 3 root 2 plus 5 minus 3, that is 2 root 3. So answer of either rational or irrational number we add or subtract. The answer is getting is either rational or irrational. Addition, multiplication, division and subtraction we can solve by this way. Now next we'll see multiply. Now we have to multiply 6 root 5 multiplied by 5 root 2 root 5. So here we are multiplying 6 root 5 multiplied by 2 root 5. As root 5 is same irrational number in both, so that will take common. So in the bracket 6 multiplied by 2, bracket complete, multiplied by root 5. So this root 5 is common, that we are taken outside, and this 6 coefficient and 2 coefficient we are going to multiply. So answer comes 6 to the 12. 12 root 5. So here also you see the rational number and irrational number, or both rational and irrational numbers are there. If we multiply, the answer is getting either it is rational or irrational number. Here root 5 and root 5 are same. So we have taken that 6 into 2 and 12 into root 5. Now this root 5 also we have to take here. So this is root 5 again. So this 6 to the 12 and this root 5 multiplied by root 5 is again root 5. But in the last lecture, or you are knowing that root 5 into root 5 we can do the multiplication because same numbers are there. So 12 into root 25. 5 into 5 because they are same. Root is same, so that is root 25. And you are knowing the square root of 25 is 5. So answer is 60. Means here root 5 and root 5 are same, that we are taken outside. So root 5 into root 5, root that is root 25. 6 into 12, that 6 into 2, that is 12. Square root of root 25 is 5. So 12 into 5 is answer 60. So here we multiply rational and irrational number or both rational number. Then answer getting is a rational number. So either the answer of multiplication, division and addition, if we add rational and irrational number, their answer is getting either rational or irrational number. Now here answer we are getting that is the rational number. So in this way we can solve the multiplication of the irrational number. Now we'll see the next part, which is different from is real number. Real number means which is rational and irrational together is called as real number. So that is the last point of the number line. First is natural number, second is whole number, then integer, then rational number, irrational number, and together rational and irrational number means real number. So a is a real number and a is greater than 0, then root a is equal to b. Here b is greater than 0 and means b square is equal to a. This I will show you by a simple example. If a is any real number, a greater than 0, that is root a is equal to b, b is also greater than 0, means b square is equal to a. Now this is called as square root because here no number is there. So it is called as 2 and that is square root. So I will show you the example. Suppose we have taken the 16. 16 is our a, means that is real number. So 16 is our real number. So root 16 is equal to answer is coming 4. So your value of a is 16 and your value of b is become 4. And therefore we can write, you are knowing 4 square is equal to 16. So this we have written in the statement that if a is any real number, then a greater than 0, comma, root a is equal to b, that is b greater than 0, therefore b square is equal to a. In short, which we take the square root of that number. 16 square is 4, means 4 square is 16. These are the opposite of each other. Square root of 16 is 4, means 4 square is 16. I will show you one more example. 25. 25 square root is 5. In short, 5 square is 25. So this is the example based on this law. So by using this, we can show any real number on the number line by geometrically on the number line, and we see how to represent any real number of the square root on the number line. Suppose we have to show the root 3.5. Now this is the number which is positive real number. A is equal to 3.5, which is positive real number. So that we have to show on the geometrically, means by using the compass we have to show this real number on the number line or by geometrically. So this is square root 3.5. Now how to show this geometrically, that I will show you. First, draw with your scale, draw the segment which is of 3.5 and give the name. Suppose you give the name AB. So you have to represent this square root 3.5 by geometrically. So first you draw 3.5 centimeter a segment. Now after drawing the segment 3.5, take 1 centimeter distance from B onwards, and where it finish, that give the point C. So first you have drawn AB as 3.5 centimeter. Then from B, which is the last point of this segment, from that you have taken 1 centimeter distance from there, that is BC, and AB is 3.5 centimeter, which you have to represent on the board. Now take the midpoint of this AC. So your AB is 3.5 and BC you have taken 1 centimeter. So total you will become 4.5 centimeter. The 3.5 and 1, that is 4.5 centimeter. So make the half of that, which will be the midpoint of this, the segment AC. So 4 half is 2 and 0.5 is 2.2 or 2.53. So somewhere it will come here. Suppose O is the midpoint of this AC. First we are representing 3.5 square root by geometrically. So first you have drawn AB 3.5 centimeter. From B you have drawn 1 centimeter segment which is increased, that is BC. then total distance become A to C, that is 4.5. So we have made half of that and we have made the midpoint of AC, that is as the O. Now take the radius OC in the compass. You have to take the radius OC distance in the compass, and by using that radius draw the semicircle from A to C. Have you understood? I told you make the midpoint of AC, then take the radius as OC and make the semicircle from A to C. So this semicircle you have drawn, that is the distance of OC, or OC is the radius of this semicircle. Now you got the semicircle. Now by you are knowing how to draw perpendicular. So by using the set square, you can draw the perpendicular line from B, which will touch to the segment, the semicircle, in the point D. So after drawing the semicircle with radius OC, draw the perpendicular line by using the set square in the compass. So BD is the line which touch to the semicircle D. So here this BD represent the number, or geometrically 3.5. We have to represent the 3.5. So in this we have represented this BD distance is root 3.5. You are knowing Pythagoras theorem. By if we use the Pythagoras theorem and if we complete this triangle, this DOB, then you can see that this BD distance will come root 3.5. That you don't want to see whether it is correct. It is coming correct, that is BD. So after drawing the semicircle, we have drawn the perpendicular line from point B, which will touch to the semicircle in D. So BD becomes the root 3.5. By geometrically we have represented. One more time I will show this how to represent any real number, which square root we have to represent by geometrically on the sheet. We have to show geometrically square root 2.5. So first to show geometrically, you have to show root 2.5 to show geometrically. So first draw 2.5 segment. So suppose this segment is PQ. First you have to draw the which square root number you have to show geometrically. First you draw that segment of that length PQ as 2.5. Now afterwards take the distance 1 centimeter and draw from Q to R. Suppose R is the point where you have finished 1 centimeter distance. So this is 1 centimeter distance. This is 2.5 centimeter distance. So in this way, now our segment becomes the PR, which total distance is 2.5 and this one, that is 3.5. So take the midpoint of this. Now 3.5, 3 half is 1.5 and remaining 5, that is 2 or 3. So it will become 1.7 or 1.8. Suppose it is coming here. So give the point as O. So midpoint of this PR is the O. So first we have drawn 2.5, then we have taken 1 centimeter more, then total distance become 3.5. We have taken the midpoint of that, half of that. So O becomes the midpoint of PR. I think up to this you have understood. Now take the radius as OR, where we have taken the midpoint. From midpoint to the last point which we have drawn from Q to R 1 centimeter, that QR, OR you have to take as the radius and draw this much distance you have to take in the compass and draw the semicircle from O to R. O is midpoint of PR. So take the distance OR in your compass and draw the semicircle from P to R. And afterward, which is your last point of 2.5 Q. Now from Q, you will using the set square, draw the perpendicular line like this. Perpendicular line is which makes the 90-degree angle. and give the name any, suppose M. So MQ, we have drawn the perpendicular line from Q and which intersect the semicircle M. So QM will represent the square root 2.5 geometrically. So in this way, any real number, positive real number, we can represent on by using the geometrically by using this method. I hope that you guys understood how to draw any real number square root by using the geometrical construction in this way. Now we see the next point from here. And nth root of a is equal to b. Nth root of a is equal to b. Then we can write b raised to n is equal to a. The same thing I have written in by another method, which I told. You see, the meaning is same. That is, if suppose we'll take 4. So 4 is the a. Then suppose square root of 4 is 2. Then 2 square is 4. The same thing I have written by using the letters. If a is any real number, then nth root of a is equal to b. Therefore, b raised to n is equal to a. So, by this way, we can represent any real number by using this. Now, for different things, different names are there. Now, when we are writing only this, then it is called as square root 16. When the number comes here, then it is called as cube root of 8. This 3 is called as cube, so it is called as cube root of 8. Suppose here fourth root of 16. So like this number we are going to say, if number is not there, then it is called as square root. If number is mentioned, then it is called as cube root, fourth root, what is there. And this sign, this is called as radical sign. This is called as radical sign. So square root of 16, you are knowing, since square root of 16 is 4. Cube root of 8. Cube root of 8 is 2. The cube root of 8 is 2, means 2 cube is 8. So you are knowing the indices. 2 cube means 2 into 2 into 2. So 2 into 2, that is 4. 4 into 2 is 8. So this is called as cube root of 8 is 2. And nothing but 2 cube is 8. Now fourth root of 16. So fourth root of 16 is equal to 2. And therefore 2 raised to 4 is equal to 16. So this sign is called as radical sign. And when there is no any number, it is called as square root. If the number is mentioned, then it is called as cube root of 8 for fourth root of 16. Suppose here written fifth root of 32. So which number is written in that sign? According to that root is taken. This is fifth root. This is third root. Here no sign is, means no number is there. So no number means square root. Here fourth root. And this sign is called as radical sign. So in this way, we can show the roots of any cube root, fourth root or square root by using this radical sign, and the sign is called as radical sign. Now you will see some identities which will be useful for solving the operation on the rational number. So some identity I will explain you, which is about the real numbers. So root AB is equal to root A into root B. This way as it means if we write, suppose 4 into 2, suppose root 4 into root 2, then we can separate it root 4 into root 2. So this is the simple law. So if it is given like this, root A upon B, then we can change it root A upon root B. We are not changing any rules. Root AB is equal to root A into B. This product we are taken of the different, then division root A upon root B means root A upon root B. So these are familiar with you. Now which is new that I will explain you. Our first identity in the rational number is root A plus root B and root A minus root B. So we'll see what is the answer of this. Now here see, same. Here also both the numbers are same. But here plus sign is there and minus sign is there. So we will do direct square of this root a. So square of this k is root a square minus square of the second, that is root b square, and square of any root is the same number, that is a, and square of the same number, that is b. So answer of root a plus root b is a minus b. Now you are familiar with this identity, a plus b and a minus b. See, the numbers in the brackets are same, but only negative signs are positive and negative signs are there. So square of the first number, that is a square, and square of the second number, that is b square. The same identity we are using. Square root of a means square of the root a is a, square root of the b is b. So this is your first identity, root a plus root b multiplied by root a minus root b is equal to a minus b. In short, you have to remember, if we write root 7 square, then answer is coming 7. Means when you make the square of root sign, then what is the number in the that radical sign? That is only its square. Like that, here number in the radical sign is a, so its square becomes a only, and here number in the radical sign is b, so its square of root b is b. So this is your first identity, a plus root b and a minus root b. So here the change is that here first number, it has no square root and other numbers have square root. It is same. So square of the first number, that is a square, minus square of the second number, that is root b square. So square of a is a square. And in the previous example I told, when you are making the square of the number in the radical sign, that answer is same. So a plus root b multiplied by a minus root b is a square minus b. So this identity is which we are used, that is same, a plus b into a minus b, that is a square minus b square. So by using this identity, we are showing this, means identity is same, but only now we are using for rational and irrational number. So further we see how to solve one or two more identities are remain, that will I explain in the next lecture. So now today I have taught you how to represent any positive real number square root by geometrically. Then I taught you which are the two types of identity and how to solve this. I hope that you have read all this in your algebra book. All the things are there. You can see and revise it. Thank you.